Yo, what's up man? It's Rising Phoenix, back at it with another video, and today I'm going to show you guys how to get Stable Diffusion running on AMD Radeon GPUs. This tutorial is specifically for Radeon 6000 and 7000 GPUs, so if you have a 7900 XT like me, or if you're running a 6800 or 6600 or whatever, this tutorial will apply to you as well. This tutorial will be done on my second computer that I will be connected to using the Windows Remote Desktop software. So if you see any visual or audio glitches, just know that it's most likely because I'm connected remotely. In any case, it doesn't matter because the setup and execution are the same anyway. Alright, so before we begin, I would just like to go over some of these system requirements. Obviously, you're going to need a Radeon 6000 and 7000 GPU with the latest drivers installed. You'll need to be on a 64-bit version of Windows 10 or 11. I don't think it matters how much RAM you have in your system, but I would recommend having at least 8 GB. And if you're a gamer, you should have this installed on your system anyway. The CPU doesn't matter either, just use whatever you have. I'm running a Ryzen 5 3600X, and my GPU is the Radeon RX 6800, which I will show you now by opening Task Manager. So as you can see here, the GPU is the RX 6800 and my CPU is the Ryzen 5 3600X. Before we continue, I just kind of want to go over what Stable Diffusion is. If you already know what it is, then just skip to the next chapter in this tutorial because this won't apply to you. So what is Stable Diffusion? So unless you've been living under a rock for the last couple of years, you'll have heard of artificial intelligence known as AI and images generated by AI. Stable Diffusion is a software that allows you to generate images using AI by simply giving it some instructions to work with. These instructions are known as prompts, and they are split into positive prompts and negative prompts. I'll explain this later in the tutorial, but for now just know that positive prompts are what you want the AI to generate and negative prompts are what you don't want it to generate. Stable Diffusion is free to use if you have the hardware capable of running it, so all the stuff you see in this tutorial is free and you don't have to pay for any of it. The support for AMD is actually quite limited, so we're going to have to install an alternate version of Stable Diffusion which has been made compatible with AMD graphics cards. To install and run Stable Diffusion, we're going to need 4 things. Number 1, Git version control software, TortoiseGit to interact with Git version control, Python, and the Stable Diffusion DirectML repository. I'm gonna explain each one of these one by one as I go through the process. So let's start by installing Git. You don't really need to understand how Git works, but just as an overview, Git is a version control software that allows software developers to keep track of changes that have been made to code bases. Alright, so to install Git, we need to open up our web browser and type git scm into Google and then hit enter on our keyboard. We then go to the git scm website. We go to downloads, Windows, and then we click on the 64-bit Git for Windows setup to initiate the download. Alright, so once that's done, we should find the download in our downloads folder. So we're going to double click on it, select yes, select next, 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 next. Just keep pressing next until you start seeing the installer running. Alright, and that's it. So Git version 2.42 has been set up on your computer. You want to untick this and then click the finish button. One of the key ways you can know when Git is installed is when you right click in a folder and you see these two options here. So open Git GUI here and open Git bash here. Alright, so next we want to install TortoiseGit. So we're gonna go to google.com again and then type in TortoiseGit. Hit enter on our keyboard. Go to TortoiseGit.org. Click the big download button and then click on the download for 64-bit Windows to initiate the download. Alright, so when we open up our downloads folder, we should find the installer here. We double click on it, hit next, then hit install. So you're going to want to make sure that run first wizard is ticked. Okay, so this git.exe path should be filled in automatically if you follow the tutorial. So if you install Git before installing TortoiseGit, you should have this already filled in. But if it's not, you just simply need to copy the path that you installed Git in and paste it into here. So I installed it in program files, git bin, and all I need to do is highlight this, right click, copy, and then just paste it into here, and that's it. So once you've got that sorted out, you click next, you tick don't store these settings now, unless you unless you want to, of course, but you don't need to do that for this tutorial. You click next and then you click finish. So that should install TortoiseGit fully and set it up. So next we are going to install Python. So if we go back to google.com and we type in Python download. Now the specific version that we need to download is version 3.10.6. So you add 3.10.6 to the end of that and then hit enter on the keyboard. So what you want to do is go to this Python release, Python 3.10.6 page, and we scroll all the way down until we see Windows Installer 64-bit. We just left click on that to download Python. And then if we go to our downloads folder, we should find Python. So we want to double click on that to start the installer. So what you want to do is make sure that this specific option is ticked. You absolutely have to make sure that this is ticked or you will have problems later on. After that, we just click the install now link. Select yes here. Alright, so once the installation is complete, you can just click the close button, and that's it. You don't need to verify anything to make sure that Python is installed. It should be all good. Alright, so the final step is to download the Stable Diffusion DirectML repository. So we're gonna head over to Google and we're gonna type Stable Diffusion DirectML. Hit enter, and it should be the first link that you see here. If we click on this, Stable Diffusion Web UI with DirectML, it should take you to this repository by this guy, I'm not going to try to pronounce that. You'll know that you have the correct repository when you see this guy followed by the slash, then Stable Diffusion Web UI DirectML. So what you want to do is come over here where it says code. You want to left click on that. Make sure HTTPS is selected. If it's not, just left click on it. Then you want to come over here to this button and then left click on it to copy this URL. And then you want to come over to your file explorer. Now you will need to select a folder that you want to store Stable Diffusion in. So me personally, I'm just going to store it in the root directory of storage drive 1. So I'm going to right click, I'm going to select git clone, and what you should see is that the URL that we just copied from GitHub, it should already be populated here in the URL section. If it's not, you go back in here, left click on code, highlight this, right click copy, and then go back into TortoiseGit and then just paste the URL here. The directory should already be populated, so you don't need to worry about that, but it's basically this path here to the folder that you want to store Stable Diffusion in. So I'm storing it in E, and it's going to create this folder Stable Diffusion Web UI DirectML inside E. So you don't need to do anything else but press OK. Alright, after that you just click on close, and that should be it as far as cloning the repository. But before we conclude the step, I just want to show you one very important thing that you need to do right after cloning the repository. So we're going to go into the Stable Diffusion folder. We're going to go scroll all the way down to the bottom until we find a file called webui-user, which should be a Windows batch file. So we're going to right click on it, we're going to click edit, and it should open up a notepad or whatever your default text editor is. And then we're going to go to this first line here, was just before the @ symbol. We're going to press enter twice on our keyboard to create a couple of lines, just like that. And then we're going to go up to the first line using the arrow keys, and then we're going to type git pull, and then we're going to click file and then save, and then we exit. So what we've just done right there is we've just told Git to basically every time we run this file, it will run the git pull command, which tells Git to pull the latest working copy of this repository. So this will ensure that you are always running the latest version of the repository with all the fixes, patches, and all the updates. You don't necessarily have to do it this way. You can always, with TortoiseGit installed, you can always go into this folder, right click into the folder, and then go to the TortoiseGit submenu here, and then all the way up to the top, at the top you just left click on git pull, and if you click OK, it will pull all of the latest updates from GitHub, and that's it. But me personally, I prefer doing it this way because it saves me the time of having to go into the folder every time and then trying to pull the latest changes every single time. So this is just a much more efficient use of time. All right, so that's kind of the basic setup. So now we're gonna go into actually running Stable Diffusion. So every time you run Stable Diffusion, you're gonna have to run it through this web UI user batch file. So what I like to do is I like to right click on the file and then go to send to, and then left click on desktop to create a shortcut. So we can now see that we have a shortcut to this exact file on our desktop, and we can simply rename the shortcut to something like Stable Diffusion DML or DirectML, right? And then every time we want to run Diffusion, we just double click on the folder on the shortcut, and you're good to go. So that's what we're gonna do right now. So it should open up a command prompt window, and you'll see that it runs the git pull command first, and then starts the setup process. Alright, so the setup process is now complete. So as you've just seen, it had to download a model, which is what's responsible for actually generating the images themselves. So after the setup process is complete, it'll give you a URL that you will see here, a local URL. So it should say running on local URL HTTP 127 or whatever this URL is. So what you want to do is, while you're focused on the command prompt console or whatever, is you want to hit control on your keyboard and then left click on the address to open up the Stable Diffusion web UI. And this is basically where you'll be doing all of your stuff, generating all of your images. Okay, so the next part is to actually test to see if it's working, right? And the only way to do that is by giving it a prompt and just giving it some data to work with to generate an image. So if you haven't used this before, you're gonna need some test data, right? So what I recommend you do is you open up a new tab and then go to Prompt Hero, prompthero.com, right? So this serves as, let me maximize this. So this serves as kind of a hub for AI generated images, and it gives people that are viewing information on how to create any of these images that you see here. So what we're going to do is scroll up to the top, and then we want to go to the search by model section and then select Stable Diffusion. We just left click on that, and then on the version section we left click on 1.5. So we're sorting by version 1.5. So then scroll through here and just basically find something that you like, right? Let me close this down. So I'm gonna scroll back up, and yeah, let's select this to work with, right? So what we want to do is essentially just kind of copy all of this, right? So this gives the model and Stable Diffusion details on how to recreate this image, right? So we just want to right click on that after we've highlighted it. We click on copy, and then we paste it into here. And then for the negative prompt, we highlight this bit, like so. Right click, copy, and then paste it into the negative prompt section. So remember earlier how I said prompts are divided into positive prompts and negative prompts. So positive prompts are what you want, negative prompts are what you don't want. So as you can see, this guy over here, or this woman, or whoever, he went into full detail telling Stable Diffusion exactly what he wanted, smoky makeup, wild blonde hair, best quality, super detailed, etc., etc. This is what he wanted, right? And then this is what he didn't want: 3D, cartoon, anime, sketches, yada yada yada, right? So he obviously went through a lot of experimentation to find out what he didn't want and what he also wanted in combination. The two helped produce this image that you're seeing here. But it's not the only thing that helped produce this specific image. I'm gonna get into that in a little bit. So once you've got your positive and negative prompts inserted, the only thing left to do is click the generate button. But before we do that, we're just gonna right click on the taskbar and open Tasks Manager, and then we are gonna go into the Performance tab here. Let's just pin Task Manager to the right and then our browser to the left. So we go to the GPU section right here. So the aim of the game is to make sure that the 3D section in the GPU tab is at like 90%. That's how we know that Stable Diffusion is actually using our GPU to create the image. So with everything set, we are going to click the generate button. All right, so we can see it running already. It's about 25% complete, and it gives you an ETA on when to expect it to be done. And we can see over here that the GPU utilization is like 97, 98%, which is a very good sign. That's how you know that your GPU is working. And we can see here in the dedicated GPU memory usage section that the memory usage has actually gone up, and we are using 8.2 gigabytes out of the 16 that we have. I'm going to talk about memory a little bit later, just to give you some more information on that. But basically, the more you use Stable Diffusion in one session, the more memory it's going to consume, and that comes with certain pitfalls. All right, so you can see that the software has actually created the image, but let's be real, it's not that great. It's not. The eyes are fucked up, they're messed up. It's just not the best. So it looks nothing like what we're seeing over here, right? So the reason why these two look so different is because of a different, this guy or this woman used a different model, right? Or checkpoint, right? So different checkpoints do different things. They produce different types of images. So what you have to keep in mind is that checkpoints are trained to do to generate specific types of images based on the prompts that are given. So if I put these prompts into a different checkpoint, it's going to produce a different image, and I'm going to show you that right now. All right, so we're going to open a new tab and then go to civitai.com. That's civitai.com. Hit enter on our keyboard, and this is another website where you can see examples of AI generated images. And the cool thing about it is that it gives you access to the checkpoint that allowed people to create said images. So you can pretty much scroll through here. If you click on the models section to sort by models and scroll through here, find something that you like I don't know, yeah, something like this, I guess. And then you simply left click on the download to download the actual checkpoint, and it gives you examples of what kind of images to expect. So you can see some people have created some realistic looking images right here, which is super cool. But the one that I like to use is called Never Ending Dream. So if let me type Never Ending Dream, NED. So it's about 3 gigabytes. So what we're gonna do is left click on this to download the checkpoint, and it should start downloading the checkpoint. All right, so if we look in our downloads folder, the checkpoint has been downloaded. So it should have the save tensors file extension. If it comes in a zip file, you just have to extract it from that zip file, and then basically just right click on it, copy or cut, right, and then paste it into the Stable Diffusion folder. Now in the Stable Diffusion folder, you'll have to go to Models, Stable Diffusion, right click, and then paste it. Okay, so the copying and pasting is now complete, and we should be able to use the new checkpoint. So if we minimize this and then go back to our Stable Diffusion browser tab, and then we click on this little refresh icon, click on it, and then we click on this arrow here, we should be able to select the new Never Ending Dream checkpoint. So left click on that, and you should see this processing thing over here. Cool, so the new checkpoint has now been loaded. So with the exact same positive prompt, negative prompt, and generation settings, we're going to just click on the generate button to see the different kind of images that will be generated here. So let's go. All right, so as you can see, the image looks a lot different, right? This looks more, it looks like a bit less realistic and a bit more, kind of fantasy, kind of mixed with a little bit of anime with a bit of realism as well, kind of combined, which is why I really like this checkpoint. It's a very interesting one. So as you can see, if we click generate again, it's going to generate a completely different image. All right, so this is the new image. Yeah, that looks a lot better. Yeah, I like that. Cool. So I'm now gonna get into some of these settings over here, right? I'm gonna start with seed, right? So every time you generate an image using Stable Diffusion, it creates a unique identifier for the image, right? And that's called a seed. So what you basically use a seed for is for situations where, say, you like an image that you have generated or an image that you have seen here or here, and you basically just copy that seed and paste it into here. Let me right click this, copy, paste it into this field right here. So when you do that, you're telling Stable Diffusion that you want an image that is similar to this, right? Similar, if not almost exactly like it, right? So it's very useful for when you want to work with a specific image. So with this in mind, I'm going to crank up the batch size. So this batch size option tells Stable Diffusion how many images to create per batch, right? So we have one batch, which is one generation loop, and in each loop it creates two images, right? So if we have this at 2 and this at 1, it should give us two images. So if we go up here and then click generate, all right, and there we go. So it's created two images in this one batch. So this is a snapshot of the two images side by side, and we can use the slider here, the image slider here, to look at each image individually, and that's how you would use the batch size option to create multiple images per batch. Now you should be careful about the batch size being too high, because if your VRAM is not big enough, you'll have a situation where it produces an error because it doesn't have enough memory to complete the generation, right? It doesn't have enough VRAM to generate the images. The next thing that I will talk about is the sampling steps. So sampling steps is basically how much detail you want Stable Diffusion to go into when generating the image. This can help up, clear stuff like, weird looking eyes, mangled up fingers, etc., etc., or maybe situations where you have hair follicles going through the ear or whatever like that, So the more sampling steps there are, the more, I guess, iterations that Stable Diffusion will go through when generating the image to produce a much higher quality image. But the higher you go, the more GPU horsepower will be needed. So if your GPU is not a specifically powerful one, it will take like hours to generate a single image. Sampling steps is best used when you have an image to a final image that you really want to perfect. Like, for example, if I wanted this one out and I really wanted to perfect it, I might increase the sample steps to, like, I don't know, 80. See what happens. If not, then 100, etc., etc. So you shouldn't just kind of crank it all the way up to maximum. What you should do is kind of crank it up incrementally. So maybe you go from 20 to 40 to 60 to 80 and then to 100. But there comes a point where you get diminishing returns, where you have the slider at a very high value, and it takes a long time to complete the image, but the image does not necessarily look better than it did before. So you're gonna have to kind of like experiment. I probably wouldn't go above 80 unless I was really trying to perfect things, to make things as perfect as possible. But I think 80 for most people should be the stopping point, really. Okay, so the sampling method also has a part to play in the image generation. So each one of these, I haven't really messed with all of these. I've only messed with a few, but each one of these will, create a different type of image. So if, for example, you wanted maybe a slightly more cartoonish image, you can play around with each one of these until you find one that kind of suits your needs. So I'm not going to touch this because this is kind of more like a basic tutorial. You're just going to have to experiment this on your own. But different sampling methods have, they tax the GPU differently. So some may use more memory than others, some may use less, etc., etc. Hires.fix is basically when you want to upscale the image from, say, 512 to whatever you've got here to a much larger one. But it uses a ton of VRAM. So if you don't have a lot of VRAM, you're gonna suffer with this. Now I know the 6800 has 16 gigabytes of VRAM, and you might think that, oh, that's enough, but not really. If I crank this all the way up to, say, if I crank the width and height to, say, 1048 by 1048, it's gonna give me memory errors telling me that I don't have enough memory, right? If I keep this at like 512 by 512, and then I use a sampling method to upscale the image to, say, 1024 by 1024, it's still gonna give me memory errors because I just don't have enough memory. Yeah, it's surprising that 16 gigabytes of memory is not enough, but hey, it is what it is. So be careful when using this, but it's free to experiment with, and I think all of the options here are self-explanatory, except for this upscaler option. This is much like the sampling method option here. So each upscaler works differently and produces different results. So you're gonna have to experiment with each and every one of these until you find the one that suits you best for the result that you want. So we're just gonna minimize this so it doesn't use the options. So CFG scale is how much creative freedom you want Stable Diffusion to have. So the higher the CFG scale, the less creative you want it to be, and the lower, the more creative you want it to be. So I think the default here is like 7, and that produces decent results, and then you can just kind of tweak this option to whatever you want to achieve the result that you want. So now I'm going to talk about this image to image option. Okay, so say you have an image that you like, whether that's an image that you've generated here, or maybe, say, an image that you've downloaded from Google, like this one, for example. If I go to pictures and then I select this Bugatti Chiron over here, and then I move it over into the window here, and then I say here, Bugatti Chiron speeding, with no negative prompts. What this will do is it'll take this image, merge it with the prompts that you've put into here, and produce a new image based on the combination of the two. So if I hit generate here, and there you go, you can see that it's taken this Bugatti over here with its colors and lights and everything like that, and it has created a new image where the car is actually speeding on a racetrack, and that's just incredible, right? And then obviously you can go down here, and then just like the text to image option, you can tweak the sampling steps and CFG scale and etc to fine-tune your image to your liking. So yeah, I mean, that's pretty much it, right? When it comes to generating the images, the last thing I'm going to show you is where the images are actually stored. So if we go back to File Explorer, and then we go to the Stable Diffusion folder. So that's Stable Diffusion, and then we click on Outputs. We click on Text to Images, the date folder. So you can see right here that it has stored all of the generated images here. So if we double click on this, we can see some of the images here, all of the images here that have been stored, that have been created, sorry. So to see the image to image images like the one that we just created here, we double click on that folder, and then yeah, there you go. There's the Bugatti Chiron speeding on the racetrack. Yeah, and that's it. This folder contains all of the grids, but this is not all that useful really. So yeah, so that's pretty much it with regards to Stable Diffusion. So like I mentioned earlier, the more you use the software, the more you use the software in a session, the more VRAM will be consumed within that session. So there are two ways to get around this, right? The first way is once the VRAM has reached its peak and you start getting VRAM errors, you can close Stable Diffusion by going over to this console here and then clicking on the close button, right? So this will terminate the session, and then you would then go back to your desktop, double click on this shortcut that we created earlier to restart Diffusion, and then you can get back into creating your images again. The second way of overcoming this difficulty is by adding some modifications to the web user batch file. So if we open this, if we edit it again, so there'll be a setting here called command line args, so command line arguments. So this basically tells Stable Diffusion how to run within its given environment. So for VRAM specifically, there are a few command lines that we can use. Alright, so if we go to Google and then type in Stable Diffusion args, and then look for this one, command line arguments and settings, and make sure it's by automatic 1111. If we scroll all the way down, we just see a list of all of the arguments that we can use for setting up Stable Diffusion in the current environment. So we can just hit Control F on the keyboard to search for VRAM. And the ones that we're looking for are medium VRAM and low VRAM. If we just highlight this, right click on it, copy, and then go back to the web user UI. After this equal sign, after command line args, we just right click and paste, right? And then we just click File, Save, and then hit the cross. Now we're going to restart Stable Diffusion by first closing it through the terminal. Then we close our browser session. We go back to our desktop, double click on the shortcut, and then fire up Stable Diffusion again. So now this time we're running with medium VRAM, as you can see here. Cool. So we're back, and this should kind of help fix some of the VRAM issues. At least that's what I did when I tested it on my Radeon 6800 a while ago. And yeah, that's pretty much it. That's pretty much it to get you started. Like I said, this is not like a super in-depth tutorial. It's just to kind of get you started, get you up and running, get you generating your images, and kind of figuring out how stuff works. So stuff like this is, it's your best friend to see what you like and try to recreate it. Download new checkpoints and just experiment and figure out what you can achieve with the software. And yeah, it's something that can that you can really put hours into, and uh, produce very interesting results. So yeah, that's it for this tutorial, man. I hope you guys found this useful, and if you did, drop a like, drop a comment, whatever you want to do. Yeah, and I will catch you guys in the next one. Peace.